Good afternoon. This is our second presentation of the group number 9, the measure step for our project. First of all, we have the project team and the company background. Then we have the problem statement in which we define the RMA, the return merchandise authorization. Then we have the Y definition, that is a KPI about the percentage of appliances with repair efficiency with RMA warranty. And then we have the general objectives, that is reduce total repair process time to increase the percentage of repair efficiency. Now we develop an analysis of the total repair time from the top to the bottom, the time per each process. Then we have a Pareto chart that shows how long both definition for each process. To the right, we have some insights that shows which technician is faster. Then we have a dot plot, and as you can see, the operator 1 and operator 2 takes the same average of days, 0.01. And here we have to Pareto chart. The first about the technician 1 and explain how long per each process, the same with another one. And with this data, you can compare each process per each technician and says which technician.
Hello, I told about the focus problem statement. Hardest focus lies in the significant difference in time between process required by technicians in the review, replace, repair, and inspect process, together with the general objective that lies in reducing the total process time. Here we have the flow chart detail the process from receipt to delivery of the material. With the help of the diagram, we section the activities that add value, do not add value, and that do not add value, but are necessary, resulting in what the graph indicate, along with the waste that is general during the process. Here we have the bottleneck that was obtained from the process time by which we could find the rate of the bottleneck that is general by technician 2. On the other hand, there are the elements of the hidden factor. In the identification of the data, we have the order of the join process to each element that is required it for data collection.
Our data collection process is as follows. 1. Define the data to consider. 2.1 Operator record reception times. 2.2 Technician record the time of the repair process. 3. Operators and technicians copy the data into Excel. 4. The effective time for each operation is analyzed. For our data collection plan, we made a 5W1A chart. At first column, person in chair was divided in integrals of group, and everyone got an operation meaning to develop. In this slide, we can see the table for data collection. The times that operators registered in the system were compared with the times that were taken manually, and in this way to verify if the information of the system is reliable. The data has a reliability of a study carried out by the technician service company, in which the data of 40 computers was generated to estimate the time required for each activity during 4 months, where the staff was involved.
The two sample t-test was performed to compare where the reception times recorded in the system differ from the times taken. The hypothesis null is not rejected since the p-value obtained is greater than 0.05 and therefore the time is met specified. A t-test was performed and it validated that this don't differ significantly as the graph shows. The p-value obtained is 0.699 greater than the level of significance. That is, the null hypothesis is not rejected and there is not enough statistical evidence to confirm that the review times of both technicians are different. Okay. The two sample t-test was performed to compare whether the replaced times recorded in the system differ from the times taken between repair times. Then, hypothesis null is not rejected since the p-value obtained is greater than 0.05 and therefore the time is method specified. With Minitab, a pre-data analysis, the Anderson Darling normally test was applied as shown in the figures below. So subsequently, the two sample t-test was performed to compare whether the reception time recorded in the system differed from the times taken manually. Okay. The same procedure was developed for the review stage. Basic statistical parameters are obtained at the times of both technicians as shown in the figures. A t-test was performed and it is valued that this don't differ significantly as shown in the graph. The p-value obtained is 0.699 greater than the level of significance. The process analysis. Here, we apply the Anderson-Darling test to confirm the normality of the data. The control chart for the individual IMR values and the moving range of the 40 data that oscillates between 0 and 6 days. The capacity analysis into the account that the maximum repair time desired by the supplier and customer is 5 days as shown in the figure. Our next step is analyze. Thank you.